Hello Year 11. Last week we were looking at empirical formula and how we calculate that. This week we're going into a little bit more detail with that, and we're going to look at how you would carry out a practical in order to work out the empirical formula. So in order to do this, we do something called heating to a constant mass. And when things are heated to a constant mass, they'll either gain mass or they'll lose mass. So when heated, some substances will produce a gas. Could be things like water vapour, which are then released into the atmosphere. These substances will lose a mass on heating. This is because the water's been given out, so the mass of the substance has gone down. Then when heated, some other substances will actually react with the gases in the air. Now generally this is going to be reacting with the oxygen. And an example of this could be magnesium. So if we were having some magnesium and we heated it with the air in the room, it would react with the oxygen and make magnesium oxide. Now the mass of the magnesium oxide is going to be heavier than the mass of the magnesium, and if we find the difference between them, that will then tell us what the mass of the oxygen that was added was, and then you can use that to work out the empirical formula. Now how we do this is heating to a constant mass. So this is a definition you need to learn. You heat the substance, allow it to cool, and record the mass of the substance. Then you repeat this process until the mass no longer changes. At the point when the mass no longer changes, that'll let you know that all the magnesium in this example has been reacted. If the mass keeps changing, that means there's still more magnesium in there that can react with the oxygen in the air. There's a few different measurements that you have to take when you're doing this. First of all, you measure the mass of the crucible. In this case, we're going to be heating solids, so that is why we're using a crucible. You then get the mass of the crucible and the substance. Now once you've got those two calculations, you know the mass of the crucible and the mass of the crucible and the substance. You can simply use these two values to find out the mass of the substance at the start. So for example, the mass of the magnesium at the start. You then carry out these continual heating, cooling and reweighing. You'll see here that the mass is gradually changing, but then you get these two readings that have the same value. So that mass is going to be the crucible, it's going to be the substance at the start, and it's going to be whatever gas, say probably oxygen, that you've added. You can then use these values, so this one as well as the first two, to calculate the mass of the magnesium, for example, that you started with, and the mass of the oxygen that was added. Then you're able to write out your table, and you've got whatever your substance was, whatever your gas was, and then you're starting out with your mass in your Mr. and you're able to work that out and put those in there, and then it's exactly the same as we did last week. So here's the practical notes. This is one of the required practicals, so when you get to your practical exam, you could have to do it, or it could come up as a written question. So first of all, we measure the mass of the empty crucible. You then measure the mass of the crucible containing some of the magnesium powder or whatever substance you're using. Here you can see they're using powder. Because the powder would have a larger surface area, it would react faster than when using a piece of magnesium. You're then heating the contents of the crucible with a lid on in a pipe clay triangle over a Bunsen burner. Notice here it's a pipe clay triangle. There's no gauze there. These crucibles have a really small base. I'll show you it in class when we get back. If you were to put that on a gauze, it would tip over and be really dangerous. So we put it in this pipe clay triangle and it fits right in there. You're then raising the lid periodically, so every so often raise the lid, let more air in. You then allow it to cool and you measure the mass, and you keep repeating that until the mass stays the same. So a few things to note. You use the magnesium powder because the larger surface area makes it react faster. It's heated to a constant mass to ensure that all of the magnesium has reacted. Something to be careful about with the lid. If you measure the mass with the lid in your first measurement of the empty crucible, you need to measure the mass with the lid every time. Probably better to just not use the lid in the mass measurements and just put it on when you're heating. Results would not be reliable without these measures in place. Any lack of reliability in the measurements would be because not all of the magnesium had reacted. Now we can have a quick look at this experimentally. So here is all of the practical stuff that you would need. You can see there what the pipe clay triangle looks like. So it's a little triangle shaped and the crucible sits right in on it. So the first step was measuring the mass of the crucible and then recording that down, so it's 27.7. You could be given a table like this to write in, or you might have to come up with your own table. Okay, then we're adding in whatever the substance is. In this case, I think it's hydrated copper sulfate, so we're going to be removing the water, so we're going to expect the mass to decrease. Our next measurement is the measurement of the mass of the crucible with the substance in it. And we're then heating it. Now remember, when you're using your Bunsen burner, you have it the safety flame when you're not using it, and then when you put it in underneath, you would turn it on to the blue flame for heating or open the air hole fully for a roaring flame. Now at this point you could put a crucible lid on it. That would help it stop reacting quite so vigorously depending on what you were using. So if you were burning something quite reactive like magnesium, you would want to have a lid on it. In this case, it's just removing some water, so it's not as essential to use a lid. You can see the colour is gradually changing. It's going from its blue colour to a white powder as the water is removed. Now, once you have heated it, you allow it to cool, and then you can pick it up and put it on the scales to find out its mass. You can see there the mass has dropped significantly, so it's now down to 28.8. So just record that in your table, and then you're going to get ready to heat it again. When you heat it again, that means that any of the substance that hasn't reacted, it will get a chance to react. And we're then looking for two measurements that are the same mass. So here we have the next mass measurement, which was 28.6. So again, the mass has gone down a bit. That means some more water has been lost. So we're going to have to do it again. And that's been heated for another 2 minutes, so we need to measure the mass again, and it's gone down to 28.5. so you would record that result in your table, and then you'll have to do it again because the mass has reduced a little bit. You can see there's no gauze there, just the pipe clay triangle on the tripod, and when it's had that 2 minutes of heating, then we can measure the mass again. If you were doing this in a classroom, you would allow it to cool because you probably wouldn't have the scales right beside you. You wouldn't want to touch it. And you can see it stayed at 28.5. So that is our final measurement. And that gives us our set of results. So last week we left out question 4. The following results were obtained in an experiment to find the formula of magnesium oxide. We have the mass of the crucible, the mass of the crucible and the magnesium, and the mass of the crucible and the magnesium oxide. The hardest bit in this is actually getting the masses correct. So your first calculation to find out the mass of just the magnesium is going to be 14.9 minus the mass of the crucible, which was 12.5. That will get you the mass of the magnesium. Then to work out the mass of the oxygen, have a think about what you would need to do. Okay, what you would need to do is the difference between these two. So you would need to do 16.5 minus 14.9, and that would get you the mass of the oxygen. Once you've got that, you could set it out in a table and go Mr. Or you can work through it like this question. You're going to have your magnesium and your oxygen, and then you're going to work out the formula of your magnesium oxide. Pause now, have a go at it, and then press play when you're ready to go through the answer. So first of all, the mass of the magnesium should have been 2.4 grams. Moles then is 2.4 divided by 24, and that gets you 0.1. Your mass of your oxygen then is 1.6 grams, and your moles is 1.6 divided by 16, which is 0.1. So if you were working down here and here, you would have had 0.1 and 0.1. We divide them both by the smaller one, They're both the same, so we divide them both by 0.1 and we end up with a 1:1 ratio. So for every 1 magnesium, you'll have 1 oxygen. And that gives you your final answer. That was the only question on this that I had in your booklet. So I'll give you another few questions to practice this technique on Google Classroom that you can work through. Have a great week.